we are going to be solving equations using logs and exponents. And the whole point of today's lesson is how to decide what formula to use while you're solving. Okay? So first thing, pop quiz. Properties of logs. This is all review stuff that we've already looked at. It might be a little weird how to fill in the blanks, and I'll go through the correct answers for that, but you see if you can fill in what we already know. You should theoretically already know all of these things. So, y equals log base a of x. It's equivalent to what statement? Rewrite it as an exponent. Second one, if log base a of m equals log base a of n, then what do you know? And same thing with the exponents. All right, so what are the rules for our bases when we are looking at exponentials? What are the rules for the base when we're looking at exponential functions? We never had our bases be negative, and we never had our bases equal to 1, because things kind of fall apart, right? We don't actually get an exponential function. So that was one of the rules. What's our rule for logs? Think about the domain when we graphed it. What was our rule for logs? It's not all reals. Look at if you look up on the chalkboard, this was a picture of a graph of a log. What x's am I allowed to plug into that? Only positive values, not 0, right? So, first one, we can rewrite this as log base a to the power of y equals the answer of x. When I originally gave it to you guys, I said log base b of the answer equals the exponent, and I said we can convert back and forth. I love my bae, her name is Bia. Base to the exponent equals the answer, right? So I use those letters to work with our mnemonic device, but you can rearrange it regardless of what letters you have. And the rule was that our base a was greater than 0. And I think a is not supposed to equal 1. It does not equal 1. Oh, and x is, sorry, that's what they want us to say. I hate these fill in the blanks, I always forget. They want us to say that x is greater than 0 because you can't take the log of a negative value, so x also had to be greater than 0. There we go. Okay, this next one. So if they have the same log base, then the insides are equal. M equals n. M, n, and a are all greater than 0 or non-negative. Greater than 0 covers all of that. They wanted us to say positive and non-negative. Greater than 0 covers everything. And then the last one, if the bases are the same and there's no extra stuff, then the exponents are the same. U equals V Again, a is supposed to be greater than and not equal to 0, and also not equal to 1. Okay, so we're going to use these rules to solve our log equations. So first one, we are trying to get x by itself. In order to get x by itself, I need to get it out of the log. The only way to get out of a log is to rewrite your log as an exponent. And remember, if there's no base written, then the base is 10. So log base 10 of x plus 6 equals 1. We rewrite this as 10 to the 1 equals x plus 6. That's it. That's the biggest thing in this entire section. Can you rewrite from a log to an exponent, from an exponent to a log, and you go whichever way you need to, and then it's just easy peasy solving. 10 minus 6 is 4, x equals 4. You do want to check your answer because you can get extraneous stuff with these. Because we're not allowed to take the log of a negative, so you want to check your answer. But log base 10 of 10 equals 1, so this one checks out. Questions? Okay, next problem. Here's the next type of problem. If I have log base 4 of something equals log base 4 of something, I can say that the middles, the insides, match. The problem I have here is the negative 2 is in the way. So I'm going to use my properties of logs and pop this up into the exponent. So log base 4 of x to the negative 2 equals log base 4 of 9. Pausing for questions, but I'm not done. Questions? Once I see that I have log base 4, I get to know that the insides, the middles, are the same. So x to the negative 2 equals 9. I'm going to rewrite this as 1 over x squared. And then I'm going to cross multiply so that I get x by itself. So I get 9x squared equals 1, and x squared equals 1/9. So x equals positive or negative square root of 1/9, which is 1/3. Now, not both of those work. Or do both of those work? Go back to the original. The very, very original. If I plug in negative 1/3, is that allowed? No, I can't take the log of a negative. So no log of a negative number. So x equals positive 1/3, negative 1/3 is extraneous. Yes. No, so when we do notes, I write down lots of extra stuff that's not necessary to put in your answer, but I do it so when you come back and look at it, you remember what we were doing. So if you just skipped right to the answer, you're like, oh, I knew that 1 over x squared equals 9. That means it's 1/3. I can't have the negative. You could skip to the answer. That's fine. You need to show some work. You can't just put 1/3. But there are parts of that you could skip. All right, number 3. So this one, I'm running into a problem because even if I move this log base 3, don't write this down. If I move it on both sides, I'm going to have 2 plus log base 3 of 9, and I don't have any way to convert things that are being added. That doesn't work for me. So I'm going to have to use properties of logs over here on the left and condense, like what we practiced on Friday. So when I condense this, I take the number in front and I pop it up into my exponent. So log base 3 of x plus 4 squared minus log base 3 of 9. And then I combine logs that are being subtracted, exponents that are being subtracted came from values that were being divided. So I have log base 3 of x plus 4 squared divided by 9 equals 2. I am definitely not done, but I'm pausing. Do you guys have questions about the condensing? Yes. Nate.
Okay, so then the log base 9 kind of gets like erased minus the 9 that goes into the denominator.
Yeah, so I condensed it, and then so when you condense it, there was only one log being written.
Okay.
There is an alternate way to solve this problem, and I can show that to you guys in a minute. Did anybody notice log base 3 of 9 you could have turned into a number? Yeah, right? 3 to what power gives you 9 as an answer? 2. So I will show you the alternate technique, but let's stick with the condensing for right now. Because if there was an x in there, you'd have to condense. Okay, so I condensed it to log base 3 of that whole big thing equals 2. And now I use my properties of logs to rewrite this. 3 squared equals x plus 4 squared over 9. I'm going to multiply both sides by 9, and 81 equals x plus 4 quantity squared. I didn't FOIL it out because now I can do this. Ta-da! So I know that x plus 4 equals positive or negative 9. Let's see if I can squeeze this all in a little better. So now my x could equal positive 9 minus 4 is 5. Negative 9 minus 4 is negative 13. And go back to your original and check to make sure that works. If I plug in negative 13, I'm taking the log of a negative, so that's extraneous. Michael.
Why did you square 3 after you had
So I rewrote this. Log base 3 of the answer equals the power. So 3, I'm going to use my highlighter. So 3 was the base. 2 was the exponent. And the answer to the whole problem was this. So I rewrote it. Oh, the purple you can, sorry, you guys can't see that. More questions? Yeah? Me?
Can you have like 2 extraneous solutions?
It's possible that there's no solution. So if you have 2 extraneous solutions, we say that there is no solution to the equation.
So you can just like, oh, I have 1 and then assume that you don't have 1.
Right. Okay, so here was the alternate. So this is a different technique. So you could have said, you still got to pop up the 2. So log base 3 of x plus 4 squared minus log base 3 of 9 equals 2. So I replaced log base 3 of 9 with its value. And now I'm going to isolate the log. Log base 3 of x plus 4 squared equals 4. And when I rewrite this, base 3 to the 4th power equals x plus 4 squared. So 81 equals x plus 4 squared. And then I would solve the same as the previous side. It's a little bit different at the beginning. Instead of condensing, I could replace that value with what it equals. How are we feeling? Yes?
Do we get a calculator on the test, or is it?
There's probably going to be calc and no calc. Probably both.
And there's some like word problem with logarithms, right?
We haven't gotten to them yet, but there could be. All right. So this one, we got logs on both sides. But look at it. All of the logs in this problem are log base 3, which is good. That means that we can condense everything. So we've got some choices. We could condense the left, condense the right, and then look for the two equal parts. That's my choice. I like that method. You could get all the logs together on one side and have them all condense, and then you would just have a number on the other side. That's fine too. And then you would use the log base to the of the answer equals the power and rewrite it. So either one works, but I'm going to use condensing. It'll help us practice what we did last week too. Okay, so first, when we condense, exponents pop up. So we're going to pop up the exponents. So I have log base 3 of x minus log base 3 of 5 squared equals log base 3 of x plus 1 minus log base 3 of 10 squared. Okay, these are subtractions. So now I'm going to write these as log base 3 of the division. So log base 3, since it's being subtracted, we do x divided by 25. 5 squared is 25. Equals log base 3. And this one we have x plus 1 divided by 100. And since our log base is the same on both sides, that means that our insides are equal. X over 25 equals x plus 1 over 100. I'm going to multiply everything times 100 to get rid of the fractions. 100 divided by 25 is 4, so 4x equals x plus 1. 3x equals 1, and x equals 1/3. Check that it's positive. It doesn't cause any of the original statements to do the log of a negative value. So 1/3 is good to go. How are we feeling?
Good.
So that's like 4 different ways that you could be working with logs. Now, if you start with an exponent, the only way to get x out of an exponent is to rewrite this using what you know about logs. So log base 3 of the answer equals the power. If it's something that you can evaluate, 3 to the 3rd equals 27. If it's something I evaluate, then I need to evaluate it. If it is something that I cannot evaluate, I don't know what power of 3 gives me 14 because it's a crazy decimal. This is considered to be your exact answer. On a no calculator test, you could leave this. If the directions say give an exact answer, you leave it. If it says round to 3 decimal places, that's the wrong calculator. Then you're going to type it into your calculator. So grab your TI calculator. If you have a modern calculator, you can go into the math menu and find log base, and it will let you type it in exactly what it looks like. So log base 3 of 14. So you go math, and you find the one that says log base, and you can type in. If you have an old TI graphing calculator, you have to use the change of base formula. So x is approximately 2.402. This is round 3 places. So if you have an older calculator, you can't find log base, or if you're like me and I don't really feel like scrolling through the math menu, you can always use the change of base formula. So log base 3 of 14 is the same as typing in log 14 divided by log of 3. So I'm just going to use the log 14, close parenthesis, log of 3, close parenthesis. I get exactly the same answer. Or if you want to, you could also use natural log of 14 and natural log of 3. All of those equal 2.402. Does this make sense? Okay, so on a calculator test, you could round it 3 decimal places. If it's not calculator, I'll say leave an exact answer. You leave the log. It's like leaving a square root. All right, let's look at number 6. This one is funky because the base is not the same. If the base is not the same, I don't know what to do. Oh no, what do I do? What do I do? Well, here's what you do. The only way to get an exponent out is to use a log. And since those two bases aren't the same, I'm not going to use log base 2 or log base 5. I'm going to use log base 10. So I am going to take the log of both sides. If this was log base 10 of 2 to the x plus 1 and log base 10 of 5 to the 1 minus 2x, I know that those are equivalent because their insides would have to be equivalent because their log bases are equivalent. Now I can get the exponent out by expanding, using the properties we had, to pull the exponent off in front. X plus 1 times log base 2 equals 1 minus 2x times log base 5. I'm sorry, log of 2, log base 10 of 2, and log base 10 of 5. I misspoke. Thank you. My mistake. I could have done natural log 2.
So like these always put either natural log.
You just took the log. So natural log and log we can use to manipulate things, and we kind of use them interchangeably. They're not the same thing, but they're convenient because 1, calculator button, and 2, they're the most common logs that get used. I'm not done yet. So now I have to distribute. X times log of 2 plus log of 2 equals log base 10 of 5 minus 2x log 5. I need to group my x's together and my other stuff on the other side. So x times log 2 plus 2x log 5 equals log 5 minus log 2. I'm going to pull my x out in front, and I have log base 10 of 2 plus 2 log 5 equals log base 10 of 5 minus log base 10 of 2. We're almost done. We're going to divide, and then we could do some simplifying on the right, or we could use our calculator to type it all in. We'll finish these notes tomorrow. There is a My Math Lab.